Hello everyone. This video is about what is the Internet of Things. I'm sure you heard of this term, and I would like to touch upon a few things. My name is Tamo. I'm a professor at the School of Information, College of Computing Information Sciences at the Rochester Institute of Technology. So my talk will consist of introduction, and before you know about IoT, we really need to understand digital evolution, fourth industrial revolution as well. Then I'm going to talk about the Internet of Things, and you might be interested in future job and industry trends. I'll be going over those, and I'll quickly go over my research overview, and I'll end with my advice. For the introduction, I would like to introduce myself. Rochester Institute of Technology is located in Rochester, New York. As you can see here, we're in New York State. It's close to Niagara Falls. We were founded in 1829. And we're at the third largest city in New York State. And we do have campuses in China, Crusade, Dubai, and Kosovo. So we have 19,000 students. And we have a 1,200 deaf and hard of hearing students. This is the place to study technology if you're a deaf and hard of hearing student. We do have a very good accommodation. And this is my website. You can check it out. I do a lot of different research within the vehicle network, data acquisition, analytic, and mobile device security, IoT, sensor, and assistive technology. And this is my lab students. Actually, there are more students. There are the students working on the vehicle area network, Internet of Things, and IoT security and assistive technology as well. So I'm currently a Chief Advisor, Program Director for IoT Program for National Technical Institute of Deaf. And I have created 2 courses, as you can see here, Foundation of IoT and IoT Analytics. And also teach human-computer interaction courses, prototyping wearable IoT, and the HCI with the mobile wearable ubiquitous computing as well. Just to briefly talk about my background, I spent about 18 years of my life at the industry, and I spent about currently 12 years at the academia. So I do have both academia and also industry side as well. I have a little bit of video here I want you to watch.
Was wäre, wenn die Autos von morgen eine völlig neue Versicherung brauchen? Weil wir heute schon an morgen denken, können Sie jetzt und auch in Zukunft auf unsere individuellen Versicherungslösungen zählen. Zürich, because change happened.
Did you get the video? Let me play a little bit again. Here's the.
Schon an morgen denken, können Sie jetzt und auch in Zukunft auf unsere individuellen Versicherungslösungen zählen.
As you can see, Internet of Things, this is possible because of Internet of Things. And you know, when you walk on the hallway, we don't collide with other humans, right? Because we can see, or we can avoid. That's what's going to happen to machines, things, cars, and they'll be able to see other vehicles, other cars, other things, and be able to avoid the collision as well, just like a human. Okay. And let's talk about the digital evolutions, where we are at this point. 1990, Internet was created. Actually, that's about 30 years ago, right? It's not that long ago, right? How long do you think that your phone has been around, Android and iOS? Anybody guess? Well, when you look at it, as you can see here, Apple iPhone was created in 2007, right? And also Android in 2008. So actually your mobile smartphone has been around for, I would say 14 years. That's not that long. Before that, we didn't have a smartphone, right? So I just want to, touch upon there's an ARPANET. This will create an internet. Actually, technical history is not that long, actually. And the cloud really took off. Artificial intelligence took off, took off around 2007. So it's not that long ago. So before, I want you to know is technology has been moving fast. It's going to be even moving faster because of the high processing power, quantum computing, all those things. So this is technology. I want to talk to you a little bit about the control evolution. Remember when I was a little child, I was in Korea actually, and I was really excited about the TV. This one has a 2-dial, right? Some household had only a 1-dial. This one we had the 2 dials. We are really excited about it. And if you want to change the channel, we have to go actually to the TV, switch it and turn the, now, remember? I probably don't remember. But after that, people realized that they don't want to go up to the TV to change channel. So they create a remote channel using an infrared, okay? And instead of, they need to point to the TV and they'll be able to switch the different channels, right? After that, what happened was instead of using a device, we determined that instead of using anything, for example, voice. So voice to control, control the light, to control the TV, control a lot of things. So we can use the voice to control those things, right? And this is we have, Amazon Echo, and there was Echo Dot and things like that. So next phase of the control evolution is actually so Internet of Things using visions, and machine can tell who are in the room, right? As you can see here, be able to track your heart rate, track your movement, track your behavior. And if you are not in really good mood, the machine learning, artificial intelligence can, evaluate you and maybe turn on the soothing music or providing a cool drinks or something like that. So without, you telling what you need, the machine can kind of figure out what you would like to have. And that's where we are at this point, right? In the future, what's going to happen is we don't want to even say, okay? We don't want to even say. So what we want to do is just thinking about what you want and be able to control things and get things. At this point, for mind control, has been doing some research in the area, but they can do very coarse command, very high level command, and they cannot, it cannot manipulate. I want to get a Miller Lite, very detailed, command. So it's been working. It's going to be around. Okay. So to understand the Internet of Things, we need to understand Fourth Industrial Revolution. Okay. So here's a video about Fourth Industrial Revolution. Let's watch it together.
Let's define what technological revolution is. Technological revolution is a period in which one or more technologies is replaced by another technology in a short amount of time. It is an era of accelerated technological progress characterized by new innovations whose rapid application and diffusion cause an abrupt change in society. 1. First Industrial Revolution. The first industrial revolution used water and steam power to mechanize production.
What this means is that they realized that instead of human doing the work, they realized that we can use water and steam to do the work for us. That was, first industrial revolution.
The major shift of technological, socio-economic, and cultural conditions in the late 18th century and early 19th century that began in Britain and spread throughout the world. 2. Second Industrial Revolution. The Second Industrial Revolution, 1871 to 1914. The second used electric power to create mass production.
What this point is saying is that they invented electricity, right? And in the first industrial revolution, they could use water to steam to do their work. But the second industrial revolution, what they're interested in is a massive production, like building cars, building, building cars, building bicycles, massive production. So they invented electricity to be able to do the massive
The
production.
second industrial revolution was another great leap forward in technology and society. New innovations in steel production, petroleum, and electricity led to the introduction of public automobiles and airplanes. In this lesson, learn about the key inventions that spurred this revolution. 3. Third Industrial Revolution. The third industrial revolution, the sweeping changes brought about by computing and communication technology, starting from circa 1950 with the creation of the first general-purpose electronic computers. The third used electronics and information tech.
This is the phase where the computers came in, right? Communication technology, computer, they made a big difference.
Technology to automate production. The third industrial revolution, How Lateral Power is Transforming Energy, the Economy, and the World is a book by Jeremy Rifkin published in 2011. The premise of the book is that fundamental economic change occurs when new communication technologies converge with new energy regimes, mainly renewable electricity. Now the fourth industrial revolution, 4IR. Fourth industrial revolution is building on the third, the digital revolution that has been occurring since the middle of the last century. It is characterized by a fusion of technologies that is blurring the lines between the physical, digital, and biological spheres. There are 3 reasons why today's transformations represent not merely a prolongation of the third industrial revolution, but rather the arrival of a fourth and distinct one: velocity, scope, and systems impact. The speed of current breakthroughs has no historical precedent. When compared with previous industrial revolutions, the fourth is evolving at an exponential rather than a linear pace.
As you can see, it's going to be more of an exponential. I mean, third industrial revolution was about the computer, and the fourth industrial revolution, it's not just limited to your laptop. It's not limited to your desktop, right? Computers are everywhere. Internet of Things, computers in the car, computers in your smartphone, and the computer you can carry. Computers are everywhere. And that's a part of Internet of Things. And also the exponential evolution is reality, because we are able to build a faster computer, faster processing. So development going to be more of an exponential than linear. Okay, you can finish watching movie at this link. Okay, I'm going to move on. So here's what the video is about in the first, second, third. We're at the fourth industrial revolution. So fourth industrial revolution consists of not just the IoT platform, mobile device, cloud computing, augmented reality. All of this is combined, okay? And what they call is a cyber physical system. Now we're getting to Internet of Things. It's the Internet of Things. What it meant is machine-to-machine communication. It's much more than connected device. And as you can see, number of connected devices has been increasing, doubling every 5 years. It's going to be double every 3 years, and or 4 years, or even 2 years as the future goes on. Okay, and when you look at the typical history of IoT, and IoT was first created, when in 1980, this guy from the Carnegie Mellon, he created connected device using Coca-Cola vending machine, and be able to determine how many Cokes are there, is it freshly arrived and things like that. And also 1990, John Rumke, what he did was he is the one who created internet for first time using TCP/IP protocol, connected to toaster. And Steve Mann created wearable IoT. 1999, Kevin Ashton. This is the time that when Kevin Ashton, used the term of IoT, and then when he was presenting at the Procter & Gamble, when he described IoT, and the 2000 IoT kind of took on. That's about 12 years ago, right? The term IoT, took on, and it became widespread. Okay. In the year 2000, LG introduced the first digital refrigerator, and the 2008. When you think about it, 2008, that was about 14 years ago. the Internet of Things, first conference was held, 2009, Google started a driving car. 2010, IoT picks, China picks IoT as a key industry to tackle financial problem. And 2013, Google created eyeglasses, and 2015, a global standard initiative for IoT, because a lot of the devices being developed by companies and they use their own standards. So what does that mean is that IoT devices from different companies, they're not able to communicate with one another. So in 2015, they decided global standard is very important. They initiated 7 years ago. Still a lot of work to be done. And 2016, I worked with the Mirai and other IoT malware. In 2017, government thinks about IoT security. This is a typical very high level of IoT history, okay? When you think about the Internet of Things, I want you to know about this. A lot of people think the Internet of Things is a collect data sensor. There's a sensor here, right? It collects data sensors such as a temperature, humidity, or motions or light, anything like that. It detects the information. Connectivity, connectivity is internet or Zigbee, deliver that information to the cloud database. A lot of people think this is this. It is just three part. It's just delivering the remote information to different location. When you think about it, that's not actually an Internet of Thing. What's valuable for Internet of Thing is a data analytic here, okay? So what do you do with all the data you collected? It has a connectivity, it goes to the cloud. What do you do with it? Does it provide the customers just the raw data? It may not make sense, right? So after to make sense of all those data, they included data analytic into it, and analytic performs a machine learning or artificial intelligence, and make sense of a lot of the big data and for business, and adjust the application as needed, right? So when you hear the term Internet of Things, you must include the data analytic as a part of the Internet of Things, okay? So when you look at the protocol standard, what are the differences? So as you can see in the middle part, it's just about the same. What's difference is that the Internet of Things, it doesn't have a lot of processing power. It doesn't have a lot of memory, okay? So the protocol has to be very light load. So they have to develop all this new protocol, like a 15.4 physical parity. So they cannot use 802.11. It's too heavy. 802.3 Ethernet, it cannot be used that. The connection, wire connection jack is too big. It does not make sense. So they have to create a very light version of the protocol they call 802.15.4. And also the application layer, the HTTP, DNS, those are the very heavy stuff. So they created their own protocol, COAP, MQTT, XMPP, and AMQP. And reason is that, utilization of web stack and the utilization of IoT stacks are different. Okay, let's think about this. Okay, when using your laptop, when you use your internet, you tend to have a more download than upload. Is that true, right? So when you watch a video, then you're gonna have a lot of download, you're gonna have a very few upload, probably acknowledgement or something. So, but then when you think about IoT, Internet of Things, you'll have a more upload than download. Think about it. When you get the sensors delivering the information, it's not about getting the information for sensor. But there are some, sensor getting the information for configuration purpose, but more than likely, what the tendency is that the IoT devices send information up, which is totally opposite of web stack, right? So that's why you need all this different protocol. So data analytics, I don't have to explain too much of this. When you use Amazon or when you use Naver, sometimes you've been browsing shoes or something, and the ad pops up, right? That's a machine learning and data analytic example. For example, this is a shoes. Is they have a sensor in there. When someone touches it, that means that someone's interested, right? And it will create a little picture of that shoes, okay? And shown on the right, it gives a more detailed information, more marketable information. Or you could have a more of an interactive here, someone can touch it and be able to see a 360 angle to see a different material. When someone touching it too, there could be a speaker coming out, I'll give you 30% off just for you or something like that, right? So another thing is that there are a lot of different examples for Internet of Things. It's consumer smart infrastructure. It will be everywhere, okay? So one thing that I want you to know is that when you think about Internet of Things, there are different value chains, a different company that you can work with. Okay, for example, smart module, sensors, sensor level, these are all the company you can work with. But those sensors, you cannot operate Internet of Things by itself, right? Those sensor has to be embedded in cars, camera, meters, appliances such as refrigerator and washer and dryer, vending machine. Those sensors needs to be in here too, right? So you can work for Samsung, Bosch, and GE, a lot of different company, as you can see on here. So those are the pretty good job prospect, right? But addition to that, all those appliances, car needs to be connected to one another because Internet of Things means machine-to-machine communication, right? So there are a lot of jobs available for AT&T, like for example in Korea, SK Telecom. Be able to connect things to things. We have to network one another, right? So our next value chain is a billing. How the analytic. How you're going to build a customer, right? And when the customer uses it, you need to build it, right? So that's the platform you have to develop as a Google, IBM, and companies like that. Also the software customization. So what it means is interface. When human or customer interfaces the refrigerator, what kind of interface do we need to have? Is to make it more efficient, right? So these are the company, and those are the application, and also goes to the customer as well. So as you can see, I want you to know there are a lot of value chains. You could work at any of this company, depends on your interest. Okay. So my next question to you is, what's the next phase other than Internet of Things? Okay. So in the future, it's going to be Internet of everything. Everything includes not just the machine, it includes the people as well. People will be a part of input and the response, part of the machine. It won't be just a machine-to-machine interface, okay? So I hope you have a very high-level understanding of what's the Internet of Things. I'd like to go into a little bit about the job opportunity. What are the industry trends? You might be interested in that. So this industry trend from a 2020 World Economic Forum, as you can see, technology like to be adopted by 2025. As more adoption occurs, right? They need more people to be able to do this, right? So there's a 2018 to 2025, those are the difference. As you can see, cloud computing, and the more and more companies are moving to cloud computing because they don't want to deal with data management, and also they need to update their servers and data center, things like that. And another thing is big data analytic. There has been a huge demand in the big data analytic, and there will be some continual increase in big data. Here's the Internet of Things, 9% increase in Internet of Things. This is shared companies. These companies, not just a technology company, we're talking about healthcare companies, technology, and also the a department store companies and things like that. Another thing is that there will be a large, when this is all open system, one of the big challenge is encryption and security. There will be a large, huge jump in, encryption and security, cybersecurity in area, okay? Those are the few things. Another thing is when you look at the different sectors, agriculture, or government, or manufacturing, or education, CIT, consumer, here's all the legend down here. As you can see, percentage of the company need Internet of Things. As you can see, lowest percentage is 74%. What's the PS? Professional services. But the rest of them, you need above 80% of services of Internet of Things, right? So another thing is, increasing demand, Internet of Things specialist is top 10. But actually, you cannot separate Internet of Things or other, because Internet of Things includes AI and machine learning, big data specialist, and the data analysis in there. Remember that it includes the data analytic, components in there. So you need all of this as well. So here is the decreasing in demand. Those are the more manual, jobs, accountant, auditor, and data entry collector, and things. Those jobs that will be going away. Okay. So here's the perceived barrier. What kind of problem are you going to face? What kind of problem company will face in the future? Companies that a lot of the older generation is they have to learn a new skill set. The biggest problem they're having is a skill gap in the local labor market. Skill gap means that do they have an understanding IoT how impacting the business, and they have to update their job skill set to meet and the demands of Internet of Things, artificial intelligence, and things like that. Okay, so that is big problems that they're currently in the United States working with the education system to update the current course load and the course identity to provide more up-to-date information. Okay, so that's the industry trend. I would like to talk to you about my research in IoT. And I want you to know that currently I do mobile device IoT security, and I got involved in this a long time ago. I don't know, more than 10 years ago, and I'm the one evaluating the President Obama BlackBerry. And at that time, the company was implementing the security solution BlackBerry. They came to me because I'm non-biased, right? Non-biased evaluator, and I was able to evaluate the President Obama's BlackBerry solution. From then on, my research kind of took off, and I've been done Android malware analysis, Android security solution. There are a lot of Android malware activities. You don't see not many of iOS activity, right? iOS security activity, because iOS, they control pretty well tight. Nowadays, I'll do a lot of IoT malware analysis. We looked into a lot of the Mirai, and a lot of the genetic malware comes from the Mirai, and IoT device security analysis, IoT malware detection using machine learning approaches as well. These are my publication, and this is a very I developed the cloud-based malware detection using Android. This is in conjunction with the RIT. I don't want to go into too detail in this, the diagram here, And this is basically doing machine learning to detect malware. But one good thing about this is we can, using your phone, we can generate a lot of virtual phones in the cloud, and each of this phone can test a particular task, and also each of this phone can, evaluate different, behavior, each one of them. So all of this is evaluation is done in parallel. So it doesn't take a long time to detect whether app or activity becomes malicious or not, right? So because it's not doing more of a serial detection, and this is done in a parallel way. So we did a lot of create a virtual box and create a lot of virtual. Each one of this perform a lot of different virtual malware. And sometimes the malware does not wake up immediately. It wakes up certain time. We monitor that continually and be able to monitor and notify the user. One good thing is that we're not using much of the actual phone, that this is all done back end, okay? So another thing is, this is IoT malware detection using machine learning algorithm. This is a student of mine worked on it. So basically, machine learning is not done not at the device level. It's done at the more of a collective level. So we use a Raspberry Pi to do the malware detection at the collective level. So it cannot be done at the sensor level because it doesn't have enough processing power and enough capability doing it. So happens that this can be done at the collective. So we are able to do some investigation, does the malware detection on it. So another research I've been doing is, as you can see, package tracking. So once you send a package, you do have a tracking, but once it arrives at the warehouse, when they scan it, right? Or when it leaves that warehouse, But in this one, we do it at the real time. And if you want to look at what your package is at real time, you might be traveling on the highway. So basically, you can, insert this box has long, what do you call that, battery power. You could include in your package. Okay, you could include when you send some the package, you could include it in the box, and you will communicate through LTE, and it will transfer that information to you on your phone where the actual location is. Okay, this is a very inexpensive way, and they're out there to monitor it. It's not a real time. You just collect the data. Once it arrives, you get the whole box and retract that data from there. It's not a really real time. Okay, and that's the very high level flavor of Internet of Things. Because of I have a limited time, I cannot go in too deeply on that. But I would like to end my talk with my advice. Remember Charles Darwin? I don't know how many of you know him or not. It's not the strongest of the species that survive, nor the most intelligent survive. It is the one that is most adaptable to change, right? What does that mean to you? I know all of you got into Sungkyunkwan University because you are very intelligent, right? You're very capable at this moment, right? So once you graduate, when you go in the work field, you got to be adaptable to the environment, adaptable to your skill sets, adaptable for your, what do you want to do? What are you good at? Okay, adapt your life, because by that time you're going to be married and a lot of changes occurs. You got to be adaptable, or you're going to be left behind. It doesn't matter whether you're from, Sungkyunkwan or, Seoul National University. If you don't adapt, you're going to be left behind. You're not going to survive because it's very competitive out there. Okay, all the technologies and business being more and more globalized, and so you'll be competing with employee or worker from halfway around the world, from China, US, and there are a lot of intelligent people out there. You got to be able to adapt and keep building your skill set. Once you get out and once you have the job, that doesn't mean that you'll retire with a good life. That means your career starts at that time. Okay. Let me give you one good example. So I'm from Rochester, New York. Have you heard of Kodak? Kodak is a film company, right? As you can see here, and the Kodak has been well known for many, many years. And Kodak is sometimes, they call a signature company for United States. And back in 1982, we had about 62,000 employees at Rochester, New York. And there are so many buildings. Right now, company has gone bankrupt and has a less than 1,000 employees. Do you know what happened? Anybody guess? Yeah, some of you, might guess that. Yes, because of digital camera. Yeah, they were resisting to change. They wanted to stay at the film because all the equipments are used for film. The people they didn't want to they didn't want to learn new technologies, and that means they have to adjust, adapt. It's a headache. They have to change all of the equipment. It's very costly. They decide not to change it. They just stay with the Kodak film. They feel that Kodak film is the future. But next question is, which company developed the digital camera? Which company? Some of you maybe guessed that, yes, Kodak created digital camera, digital technology, okay? And even though they created the digital technology, they resisted in changing it. And what happened was the Fuji, the Japanese company, looked at the patent. That's really interesting. And they bought the patent to be able to manufacture the digital camera. So they bought the patent, and the rest is history, right? Fuji took off, then Olympus, Canon, and a lot of companies are taking on digital cameras, right? You can do so many things. And this happened because Kodak fell because they resist to change to their own invention. And the Kodak used to have about 212 buildings within Rochester. Right now they have less than 10, and they have donated to many buildings to RIT, the University of Rochester. They didn't want it because the maintaining costing too much money. It's too far away from the campus, so it was going ruined. Just they have to demolish a lot of the buildings. Okay, so I want you to think that you yourself is your own company. Okay, you yourself is your own company. Yourself is I prefer. So I don't have a company. No, yes, you do. You yourself is your own company. How can your company be more attractive to investor? How can you make yourself more attractive to the company? Like, how can you grow your company, right? So one thing I want you to know that all the CEOs, all the company, they don't make the major decision based on what he knows, right? So what he knows, because they have all this advisory boards, expert from academia, a lot of different industry comes to and makes the decisions, okay? So you need to have an advisory board. If you need a career advice, you can go to Professor John, and he can ask you. You don't have to let them know that you're in their advisory mode. And for example, if you have a problem with their, a girlfriend, you can go somewhere else, or someone that you maybe a pastor or someone, right? I think you catch what I'm saying. So I want you to know that you need to take care of yourself, keep growing, try to be adaptive, okay? I put the KSA here in America. We have a American Scientists and Engineering Association. We really work hard to provide that mentoring to a lot of the students here. And, I hope that you can find a mentor who can give you a lot of motivations, a lot of purpose in your life. Thank you. That's my talk. I hope you have a wonderful day, and thanks for watching this video. Okay.